Hi everyone, welcome to the study of nonlinear O.D.E. We are looking at how we can solve this O.D.E which we are given y double prime minus 3y prime plus 2y which is equal to x exponential x plus 2x. So we are going to first of all get the reduced form as follows. Reduced form of this equation is equal to y double prime minus 3y prime plus 2y which is equal to 0. And to solve this reduced form, we are going to let our y to be equal to exponential mx. Then we differentiate our y to get y prime, which is equal to m exponential mx. Then we get y double prime, differentiating y twice to get m squared exponential mx. Then we substitute these values here, where you have y double prime, you write m squared minus 3m plus 2 everything exponential mx, factoring exponential mx, this is equal to 0. Now, in this case, exponential mx can never be equal to 0, meaning that our m squared minus 3m plus 2 is the one which is equal to 0. And this is a quadratic equation which can be factorized to obtain the following. So we can factorize this quadratic equation to get or to obtain m minus 1 into bracket m minus 2, which is equal to 0, meaning that our m1 is equal to 1 and our m2 is equal to 2. Now, our complementary part will be yc is equal to c1 exponential x plus c2 exponential 2x. That is our complementary part. Now, to get the other part, the particular part, we are by use of what is called method of variation of perimeter. By method of variation of perimeter, we are going to let our u1 to be equal to u1 of x, which is equal to c1, and our c2 to be equal to u1 u2 of x, which is equal to u2. So that now we obtain our u1 prime y1 plus our u2 prime y2, which is equal to 0, and our u2 prime y1 prime plus our u2 prime y2 prime is equal to r of x. In our given O.D.E, r of x is equal to x exponential x plus 2x, and y1 is equal to exponential x, y2 is equal to exponential 2x. So substituting those here, we shall have u1 prime exponential x plus u2 prime exponential 2x, which is equal to 0. So differentiating this, we shall have u1, this is 1, sorry, u1 prime exponential x plus 2 u2 prime exponential 2x, which is equal to our rx is x exponential x plus 2x. Then from linear algebra, we can rewrite this in terms of matrix x exponential x, but just exponential 2x, 2 exponential 2x. We put this into bracket, multiplying by u1 prime, u2 prime. This is equal to 0, x exponential x plus 2x. From this part now, we do what is called the Wronxian. The W stands for Wronxian of y1, y2, which is equal to determinant of exponential x, exponential x, exponential 2x, 2 exponential 2x. determinant here. This will give you 2 exponential 3x minus exponential 3x, which is equal to exponential 3x when you subtract. From there now, you shall obtain u1 prime, which is given by determinant of 0 x exponential x plus 2x exponential 2x 2 exponential 2x. We obtain the determinant. This of course here will be over Wronskian, which is exponential 3x, so which is equal to exponential negative 3x, taking Wronskian you have into bracket 0 minus x exponential 3x minus 2x which is equal to exponential 3x into bracket x exponential 3x minus 2x exponential negative exponential 2, this is positive, sorry, exponential 2x. We can remove the bracket here, so u1 prime is equal to x minus 2x exponential negative x after removing the bracket. Note that there is a negative here and even this other part there's a negative. So to obtain u1, we integrate this will give you negative x over 2 minus 2 into bracket. This one we are going to integrate it by part to obtain the following result. So when we integrate this by part, we shall obtain negative x exponential x. This other part here, it is going to give you minus exponential negative x. So that is what we shall obtain, which can be simplified to give you the following. On how to integrate by part, you can check in my channel so that you may see how we easily integrate by part. So this is negative x squared over 2 plus 2x exponential negative x plus 2 exponential negative x. So that is our u1. Our u2 will be given by the following of exponential x 0 x exponential x plus 2x over the Wronskian, which is exponential 3x, which is equal to exponential negative 3x into bracket. Here you shall have x exponential 2x, then minus 2 x exponential negative, sorry, exponential x. So u, meaning that our u2 prime is equal to x exponential negative x minus 2 x exponential negative 2x. So to obtain u2, we integrate, so you shall have x exponential negative x in integral minus 2 into bracket x exponential negative 2x dx. So we shall integrate this by part. When we integrate by part, the first part, we are going to obtain the following. So you shall obtain here negative x exponential x integrating by part minus exponential negative x. This part here, when we integrate by part, this is what we obtain. On how to integrate by part, kindly check in my YouTube channel so that you may see how we can integrate this part by part. in a simple step method minus this other part here will give you negative x exponential negative 2x minus half exponential negative 2x. So that is our u2, which can be simplified to obtain the following. So in the first part here, we can factor exponential negative x so that we get negative x minus 1. The other part, we can factor negative exponential negative 2x so that we'll be left with x plus half. Then from there now, we are going to get yp. Yp is given by u1 y1 plus u2 y2. So we substitute our u1, we obtain as negative x squared over 2 plus 2x exponential negative x plus 2 exponential negative x, everything. We multiply by exponential x plus exponential 2x into bracket minus x minus 1 multiplied by exponential negative x, then minus exponential negative 2x multiplied by exponential 2x into bracket x plus half. I'm substituting this part here, which will give us the following. Here we shall have negative x squared over 2 exponential x plus 2x plus 2, this part here, plus exponential x into bracket minus x minus 1, then minus bracket x plus half, which can be simplified if need be, because we have this part here with the x and the other part with the x. So we can combine this part here with the x. Here you have 2x minus x. So this is equal to minus x squared over 2 exponential x. You have 2 minus half, which will give you, let me collect the terms with the x. So minus x squared, this one, plus x, because this is 2x minus the x here, so you'll be left with the x, then plus exponential x into bracket minus x minus 1. Then you have 2 minus half, which is 1 and a half, which is the same as plus 3 over 2. So that is the part we have. So our solution, our given O.D.E was y double prime minus 3y prime plus 2y is equal to x exponential x plus 2x. So our solution of the given O.D.E will be y, which is equal to y complementary plus yp, which is equal to c1 exponential x plus c2 exponential 2x, then plus this other part here, minus x squared over 2 exponential x plus x, then plus exponential x bracket negative x minus 1 plus 3 over 2, which can be simplified if need be. So thanks so much for taking your time to study with me on the nonlinear O.D.E whereby the coefficient is undetermined. For more such working, kindly tune to my YouTube channel so that we may continue learning together. Bye bye, see you in the next video.